Welcome to the West video series. My name is Enrico Remigi and I'm the process modeler in the West development team. In this video I'm going to show you how to mimic non-ideal mixing conditions in a tank, for instance an activated sludge tank. And I'm going to use for this the model editor tool of West, and then the main West environment to set up and run a sample case. Now, the starting point for our discussion here is that most process models assume ideal mixing in the tank, also termed CSTR, which is the case for the fixed volume ASU model in West, which describes the hydraulic behavior of an activated sludge tank with constant volume. Now, if the real conditions should be far from ideal, evidently the base CSTR model is not going to be appropriate. And this is the reason why West offers an alternative, a set of alternative implementations from 2 up to 10 ideally mixed compartments for an activated sludge tank. But the question is now, how can I choose how many compartments are appropriate for a given situation? And one way is clearly to conduct a tracer test on my real scale tank, to spike a certain amount of non-reactive soluble substance, the tracer, and to measure the recovery of that same substance at the outlet of the tank. Then to model the test and comparing the measured data set with the output of the simulation. And this is what I would like to demonstrate in the video. For this, I've started up the West model library of 2016, and I'm going to open the block library, which I must warn you, I have modified from the official West 2016 release by adding this custom category copy of the ASM1 called ASM1 mod. And I've illustrated this process in another video regarding the addition of new components to a category. So I invite you to watch that video that covers a lot of the concept that I will use here. So now in this category I want to add a new component which I'm going to call S-tracer. And since it has to be a soluble component, I'm going to move it within the soluble group here and down here. I'm going to check the Guyer matrix if I have my new component. There it is, flagged correctly as soluble and with no stoichiometry coefficients, which is correct, so it doesn't take part in any of these reactions, which means it is effectively a non-reactive soluble component. And next I'm going to update or generate the code. There we go. If you've watched the video I referred to earlier, the next step, you will know that the next step to do is to update the initialization of the M vector, the mass vector, in the WWTP base MSL file. So I'm going to open the code editor, scroll down to the definition of this object, this vector M, obj M. This is the block pertaining to my ASM1 mod category. All I need to do is just duplicate, copy this element from opening curly bracket to the comma. Then Ctrl S to save. Right, I can then go back to my block library explorer and save my block library. Optionally, and is always a good practice, I can check my instance. Check was successful. Now I can use the changes I've made to simulate a tracer test study in West. Right, so I'm going to now create a new project. It points to the right library, right instance. I'm going to call this video tracer test. Right, and now I'm going to drag an equalization tank block and change its model to fixed volume equalization tank in the properties pane class name property. And then I want to to have, let's say, 5 tanks. So I'm going to replicate this tank 4 times. In this way, save having to reset the model every time. And I'm also going to use an industrial wastewater input block, which I'm going to call tracer input. Connect these icons, these blocks. And this is really all I need in terms of waste layout to simulate my tracer test study. So how am I going to use this model to interpret my experimental findings and ultimately to determine the most appropriate number of compartments that should be used to correctly describe the hydraulic behavior of my real scale activated sludge tank? I have here my tracer input, which I'm going to associate in a minute to an input file that I have prepared with a spike of a tracer element, a maximum of 5 tanks in series, and I will then compare the recovery of the tracer that I've measured at the outlet of my real scale activated sludge tank, also in a separate file which I've prepared, to the theoretical simulated recovery that would be measured at the outlet of each of these tanks in series. The curve that will best fit my measurements will correspond to the number of compartments that I should then use for my activated sludge tank model. Now to do this, I'm going to first create, associate the input file to my input block. I'm going to switch to the standard. Influence specs, data import, I'm going to read in a file that I have prepared, which is this one, tracer test. Like this, generate the necessary influence files. There we go. First operation. Then I will create a new sheet and a new plot. For the plot, I'm going to choose the line type. And multi-select my 5 tanks. From the block details now, I will drag the S-tracer element of the C, so the concentration vector. This will create the 5 data series for the concentration of tracer in the 5 compartments. And for my experimental data, I will use this option add series, switch the source type from experiment to file, and browse to the file that I've prepared for my measurements, which is called the test tracer measurements. There it is, and select the measurements like this. Very well. Now I can launch the dynamic simulation. I know that my data set, I can simply run restrict the simulation horizon to only 2 days. Then launch. Actually, I forgot, sorry, to switch the output frequency to something more meaningful. Run the simulation, and there we go. So how can I interpret the results of the simulation? I can certainly turn this off and probably this one as well. So conclusion would be that my real scale tank behaves pretty much like a 3 tank in series. You see here, this is the curve. These are my measurements between two, 3 and 4 compartments, like 4 compartments in series. So I would now go back. Obviously, it's a separate project, but I just wanted to show you what I would do. I would, in my activated sludge unit block, actually select the 4 4 tank in series model. Thank you for taking the time to watch this video, and please come back for more. Goodbye.